Chapter 1, Part 1, The Flag on Screen 7. The red flag appears on monitor 7 at exactly 11:52 UTC, 5 minutes after perihelion. You glance up from your data terminal at NASA's Deep Space Network Center, watching as the alert pulses silently. Someone has muted the audible warnings. Too many false positives lately, but this one isn't false. Screen 7 shows 3I Atlas's light curve during closest solar approach, and the pattern is all wrong. The curve should be rising sharply as solar heating vaporizes the comet's icy surface, creating a brilliant coma, visible even in small telescopes. Instead, the brightness remains flat, unchanged, as if the sun's blistering radiation 203 million kilometers away is having no effect whatsoever. Across the room, Dr. Levinson notices it too. Her coffee mug freezes halfway to her lips. "That can't be right," she whispers, but the microphones pick it up anyway. Before we follow what happens next, take a moment to calibrate yourself to what we're witnessing. This isn't speculation about a future event. This is happening now. October 29th, 2025. The day humanity's third confirmed interstellar visitor faces its greatest test. Wherever you're watching tonight, perhaps a darkened room in Seattle, a morning commute in Tokyo, or afternoon break in Cape Town, welcome to Sapiens Untold. This channel has expanded beyond ancient mysteries to explore cosmic ones, interstellar visitors, astronomical anomalies, and humanity's quest to understand our place among the stars. Where are you watching from, and what time is it where you are? Get comfortable. Dim the lights if you can. We're about to witness the pivotal moment when an object from another star system reveals its true nature under our sun's unforgiving glare. If cosmic mysteries like this pull at you the way they pull at me, hit like and subscribe now. Let's return to that flat light curve and what it means. The mission control room buzzes with urgent whispers. The data contradicts every predictive model. Natural comets respond to solar heating. It's physics, not preference. Ice sublimates to gas. Gas forms a coma, pressure builds, activity increases. This is the immutable equation of cometary behavior at perihelion. It's how nature tests what comets are made of. Yet Screen 7 shows a visitor defying these fundamental rules. In the adjacent displays, telescope feeds from observatories worldwide confirm the anomaly. No dramatic brightening, no expanding coma, no visible outgassing, despite the sun's radiation now hitting with maximum intensity. Someone pulls up the comparison charts. Data from 2I Borisov at similar solar distance. The contrast is stark. Borisov behaved exactly as expected, brightening dramatically at perihelion, developing tails of dust and ionized gas, a textbook interstellar comet. But 3I Atlas, it's passing through the same crucible and showing almost nothing, as if it isn't made of ice at all. That's Chapter 1, Part 2, Plotting the Hyperbolic Arc. The trajectory visualization appears on the main screen, pulling everyone's attention from the flat light curve on monitor 7. A glowing white parabola cuts through the solar system map, 3I Atlas's path. Operators overlay a second curve in pale blue, the predicted trajectory based on gravity alone. They don't align. The two lines diverge by thousands of kilometers, a gap that grows with every new data point streaming in from telescopes worldwide. This isn't an instrument error. It's a physical deviation from the laws of orbital mechanics. Someone types a command. A third curve appears in red. Oumuamua's trajectory from 2017, scaled and rotated to match 3I Atlas's path. The room goes silent. The red and white lines trace an almost identical pattern of non-gravitational acceleration. The perihelion test is now presenting a profound contradiction. The flat light curve and the absence of a visible coma suggest no outgassing is occurring, yet the trajectory data shows the object is accelerating, as if being pushed by an unseen force. The very effect that outgassing is supposed to create, it has the thrust without the exhaust. This is the central mystery that made Oumuamua so controversial. For a natural comet, the equation is simple. Solar heating causes outgassing, which creates a gentle, measurable push. The two phenomena are inseparable, but 3I Atlas, like Oumuamua before it, is breaking this fundamental rule of cometary physics. You watch the numbers scroll across the display, confirming the deviation is statistically significant, well beyond any margin of error. The data is pouring in from the global network of observatories from Chile to Hawaii, each one confirming the same impossible observation. The natural origins advocates in the room scramble for an explanation. Could it be the sublimation of an exotic, transparent ice that our instruments can't detect? Perhaps a strange form of hydrogen ice, as once proposed for Oumuamua, but that hypothesis has been largely discarded due to the physics of hydrogen sublimation in interstellar space. Every conventional explanation strains to fit the data. Meanwhile, the anomaly investigation camp sees a repeating pattern. 2 objects in 8 years, both from interstellar space, both exhibiting the same unexplained acceleration. As you stare at the 2 diverging curves on the screen, the path gravity dictates, and the one this visitor chooses, you realize the Perihelion test hasn't simplified the mystery, it has made it undeniable. Chapter 2, Part 1, A Point of Light That Moves Too Fast. The radar pulse fires from NASA's Goldstone facility at 1322 UTC. 95 minutes after perihelion, you watch the live feed as the signal races outward at light speed toward Mars's orbit, where 3I Atlas has just emerged from its closest solar approach. 18 minutes later, the first returns echo back, painting a picture on the monitoring station. The numbers that materialize on the screen shouldn't be possible. Velocity, 38.7 kilometers per second. The technician runs the calculation again, then a third time. There is no error. The interstellar visitor is moving nearly 9 kilometers per second faster than it should be, based on the sun's gravitational pull alone. This isn't the gentle, predictable acceleration of orbital mechanics. This is a significant, unexplained push, happening just after the moment of maximum solar heating. Right now, as you watch the velocity tracker, 3I Atlas is accelerating as if fleeing the inner solar system. Check this against gravitational models, someone calls out. Within seconds, the comparison appears on the central display. 2 curves, the expected velocity profile in blue and the actual radar measurements in white. They began to diverge hours before perihelion and are continuing to separate with each new data point. The room grows colder as the implications settle in. The anomalies that made Oumuamua so controversial 8 years ago are happening again, but this time they are being recorded in real time, under the unwavering gaze of Earth's most powerful instruments. There are no gaps in the observation, no ambiguity from late detection, just a continuous, multi-spectrum stream of data telling an impossible story. Right now, telescopes worldwide are locked onto this phenomenon. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, radio arrays across 5 continents, all are aimed at a single point of light that is moving too fast. Their findings feed into the same data pool, building a comprehensive portrait of an object that seems to be breaking the rules. The perihelion test was supposed to settle the debate, to confirm 3I Atlas as just another exotic but natural comet. Instead, the verdict being written in photons and radio waves is deepening the mystery. It is accelerating without a visible cause, holding itself together when it should be cracking apart, and reflecting light in ways no comet should. The observation window is precious. Every hour counts. The European Southern Observatory has just come online as night falls over the Atacama Desert. Its adaptive optics system is now resolving the faint point of light with startling clarity. Radar cross-section analysis coming in, the system announces. More numbers appear on an adjacent screen, suggesting a solid, dense object roughly 1.2 kilometers in diameter, not the porous, loosely packed rubble pile of a typical comet nucleus. The Sun has performed its test. Now, scientists are faced with results that challenge the very definition of what travels between the stars. Chapter 2, Part 2, The Absence of a Coma. The high-contrast imaging feed from Mauna Kea appears on the main display at 14:06 UTC. It's early morning in Hawaii, the sky a perfect clear black. The Subaru telescope's adaptive optics system hums, cancelling out the shimmer of Earth's atmosphere to deliver an unprecedentedly sharp view. The image resolves, revealing 3I Atlas not as a fuzzy, indistinct smudge, but as a stark, point-like object surrounded by nothing. No coma, no diffuse cloud of gas and dust, no hint of a tail stretching away from the sun. The imaging specialist pushes the contrast, darkening the background to reveal the faintest possible structures. The screen refreshes. Still nothing. The absence of a feature screams louder than any observation could. This is the most visually damning evidence yet from the perihelion test. At this distance, 1.37 astronomical units from the sun, baked for hours at over 300 Kelvin, any comet rich in ice should be a spectacle of furious outgassing. The physics is not optional. Water, carbon dioxide, carbon monoxide. These volatile ices cannot remain solid under this thermal assault. They must sublimate. But the images streaming in from Hawaii show a body that remains inert, impassive to the sun's fury. Pull up the Borisov comparison, someone requests. A second image appears beside the first. 2I Borisov at a similar distance in 2019. The difference is shocking. Borisov is a classic comet, a bright extended coma, tens of thousands of kilometers across. with a faint tail just beginning to form. It passed nature's test with flying colors. 3i Atlas is failing in plain sight. The James Webb Space Telescope, trailing Earth in its orbit 1,000,000 miles away, now adds its infrared eye to the campaign. Its instruments can detect the faint thermal glow of outgassing, even if it's invisible to optical telescopes. The first Webb data appears at 1422 UTC. The spectrum is flat. No water vapor signature, no carbon dioxide, no methane. All the chemical fingerprints of sublimation are missing. The global observation has become an exercise in documenting absence. The missing coma, the missing spectroscopic signatures, the missing signs of fragmentation. Like a detective examining a room for what isn't there, astronomers are cataloging everything 3i Atlas is failing to do. Natural explanations are becoming increasingly strained. A thick crust of non-volatile material? It should have cracked under the thermal stress. An object that has already exhausted all its ices? That wouldn't explain its non-gravitational acceleration. For the researchers who study anomalies, the data paints a consistent picture. An object with a solid, non-icy composition being pushed by a force other than outgassing. The Perihelion test, designed to prove this object was a natural comet, is instead providing a mountain of evidence to the contrary. The simplest, most fundamental signature of a comet, its coma, is nowhere to be found. Chapter 3, Part 1, Reading the Object's Light Curve. The photometric data unfolds across your screen in real time. A line graph tracking the minute-by-minute brightness of 3i Atlas since it passed perihelion 3 hours ago. Each new point on the graph is a photon of light captured by a telescope that traveled 200 million kilometers to tell its story. And the story it tells is not one of a natural comet. Brightness oscillation period, 7.8 hours, the analysis software reports. But it's the shape of the wave that makes the room go still. It's a perfect sine curve. The object's brightness is varying with a clock-like regularity, rising and falling by a precise 0.36 magnitude with each rotation. There is no chaotic tumbling, no unpredictable flare-ups. Right now, at this very moment, astronomers from Hawaii to Chile are watching this same graph draw itself across their screens. Each new data point from each new observatory lands exactly where the perfect sine wave predicts it should. Natural objects don't do this, the senior astronomer beside you murmurs, her voice tight with disbelief. They tumble, they're lumpy, irregular. Their light curves are a mess, especially comets at perihelion, with jets of gas firing off at random, changing the spin, changing the brightness unevenly. But 3i Atlas is not behaving like a natural object. Despite the intense solar heating that should be wreaking havoc on its surface, it spins with the perfect stability of a gyroscope. The baseline brightness isn't rising, confirming the lack of a developing coma. There is only the rhythmic, mechanical pulse of its rotation. You watch as the system pulls up the light curve from 2i Borisov for comparison. The difference is profound. Borisov's graph is a chaotic scrawl, a testament to its nature as an irregularly shaped, outgassing piece of interstellar rock and ice. It looks organic, unpredictable. The light curve for 3i Atlas, by contrast, looks engineered. This observation on its own is not definitive proof of anything. A strangely symmetrical natural object is not impossible, just highly improbable. But layered on top of the lack of outgassing, the unexplained acceleration, and the anomalous chemical signatures, it adds another powerful piece to a puzzle that no longer resembles a comet. The perihelion test continues. Its results are being written in the photons arriving from deep space. And this particular chapter, told by the object's light, suggests a visitor with a stability and regularity that nature rarely produces. The perfect repeating wave feels less like a random astronomical observation and more like a transmission. Chapter 3, Part 2, The Albedo Problem. The reflectivity calculations appear on screen 4 at 15:08 UTC, sent from the team at NASA's Jet Propulsion Laboratory. They've been measuring the precise amount of sunlight 3i Atlas reflects back into space as it emerges from perihelion. The number that materializes on the screen is 0.74. The figure hangs in the air, a stark piece of data that makes no physical sense. This is the object's albedo, a measure of its reflectivity. An albedo of 0.74 means it is reflecting 74% of the sunlight that strikes it. For context, fresh snow has an albedo of about 0.9. The dark, carbon-dusted surface of a typical comet has an albedo between 0.03 and 0.06. They are some of the darkest, most light-absorbent objects in the solar system. This visitor, however, is shining with a reflectivity that rivals the icy moons of Jupiter. It is not just unusual for a natural comet, it is nearly impossible. "Run the calibration again," someone orders, their voice tight. But this isn't the first reading. Over the past 4 hours, 3 separate observatories using different instruments have all returned the same value. 3i Atlas shines like polished metal, not the lump of sooty ice it was supposed to be. Right now, as you watch the thermal imaging data stream in from the James Webb, the contradiction deepens. Despite its high reflectivity, which should keep it cool, the object's surface temperature indicates it is absorbing and conducting heat with remarkable efficiency. It is simultaneously a mirror and a radiator, a combination of properties that doesn't exist in any known natural cometary material. The Perihelion test is peeling back the layers of this object one by one. The sun's fire has revealed a surface that no one predicted. The high albedo helps explain the lack of a brightness surge. The object is simply intrinsically bright, but it raises a much more profound question. What is it made of? The natural origins advocates propose a recent impact that exposed a vast uniform sheet of pristine ice. But the reflectivity is too high even for fresh ice, and it is perfectly consistent across the entire rotating body. Others suggest exotic crystalline structures forged in the unique conditions of interstellar space. For the anomaly researchers, the high albedo is a key piece of evidence. It is consistent with a smooth metallic surface, the kind of material one might use to build a structure designed to travel between stars and manage extreme thermal loads. The object is not just failing the perihelion test, its properties seem to align more closely with technology than with nature. Every new photon arriving from 200 million kilometers away adds weight to an extraordinary conclusion that most in the room are not yet ready to speak aloud. Chapter 4, Part 1. On the slopes of Mauna Kea, the adaptive optics system on the Keck 2 telescope hums, its laser a thin, steady line of sodium yellow light aimed at the heavens. You are in the control room nearly 14,000 feet up the slopes of Mauna Kea, where the air is thin, and the boundary between Earth and space feels almost non-existent. It is 4:37 a.m. local time, October 30th. 9 hours have passed since 3i Atlas endured perihelion, and for the last hour this 10-meter eye has been staring at it. AO lock confirmed, the technician says. On your monitor, the image sharpens into a focus impossible from anywhere else on Earth. The shimmering blur of a distant star collapses into a perfect point, and next to it the target, 3i Atlas. What you see is not a comet, at least not like any you have ever seen. There is no fuzzy, expanding halo of gas. The object is a crisp, hard point of light. The adaptive optics are so precise that the system can begin to model its shape. The data suggests not a lumpy potato-like asteroid, but something with defined, almost geometric facets. Surface integrity scan is running, the operator notes. This is the other crucial part of the perihelion test. The thermal shock of its solar passage should have been immense. Comets are fragile things, loose collections of ice and dust that often crack, fracture, or disintegrate entirely under such stress. They're expected to fail this test, but the data scrolling on the screen shows no signs of fragmentation, no new cracks, no debris field. The object has passed through the furnace and emerged utterly unchanged. It has held together with a tensile strength that a body of ice and rock should not possess. The perihelion test was designed to break this object, to force it to reveal its icy heart. Instead, its resilience is what's revelatory. The object is not just inert, it is strong. The natural origins camp struggles to fit this into their models. Perhaps it is a solid body of nickel iron, a shard from the core of another world, but that doesn't explain its acceleration. Each piece of evidence that solves one anomaly seems to contradict the evidence for another. For the anomaly investigators, however, the data from Keck is a perfect fit. A solid metallic structure would easily withstand the thermal shock of perihelion. It would not fragment. It would have the strength to maintain its form. The photons captured here, on this dormant volcano in the middle of the Pacific, are telling a story of impossible resilience. The sun did its best to destroy this visitor. The fact that it failed tells us more than any explosion ever could. Chapter 4, Part 2, The Test That Breaks Comets. The historical comparison slides appear on the main display at NASA's Goddard Space Flight Center. A visual catalogue of cometary destruction. It is 21:47 UTC on October 29th, 10 hours after 3i Atlas made its closest approach to the sun. You watch as images fill the screen. A stark reminder of what this test is supposed to do. Comet Shoemaker-Levy 9, torn to pieces by Jupiter's gravity before it even reached the sun. Comet Ison, a brilliant sun grazer that simply vanished in 2013, having disintegrated in the solar furnace. Comet 73P, Schwarzmann-Wachmann, captured by Hubble in the act of breaking into dozens of fragments. This is what the sun does. It is nature's crucible, a test of structural integrity that comets, by their very nature, are expected to fail. They are fragile conglomerates of ice and dust, barely held together. Then the final slide appears, a live, high-resolution feed of 3I Atlas. It is pristine, unchanged. It has endured the same gravitational stresses, the same thermal shock, and it shows no signs of fragmentation, no debris trail, no cracks. It has passed through the fire and emerged whole. This is unprecedented, the mission lead says, her voice echoing in the quiet room. We're witnessing a complete failure of all 4 cometry test parameters. On the screen, a diagnostic checklist flashes red, one line after another. Structural integrity test, failed. The object did not fragment. Outgassing test, failed. No coma or tail detected. Composition test, failed. No water, CO2, or other expected volatiles. Photometric test, failed, anomalous albedo and rotation. 8 years ago, with Oumuamua, the data was incomplete, allowing for a range of natural explanations to fill the gaps, however strained, but not this time. Right now, the global astronomical community is watching these results unfold with a clarity that is both breathtaking and deeply unsettling. The data is unambiguous. The natural origins advocates are now forced into proposing ever more exotic scenarios: a pure iron-nickel body from the core of a shattered planet, a comet with a bizarrely resilient outer shell of unknown material. But none of these explanations can account for all the anomalies simultaneously. An iron body wouldn't accelerate, an icy body would have cracked. The Perihelion test was supposed to provide a definitive natural answer. Instead, the verdict being delivered by the sun is forcing a paradigm crisis. If an object fails every single test for being a natural comet, what is the alternative? As you watch the unblemished point of light continue its impossible journey, the unspoken question hangs heavy in the air. Chapter 5, Part 1, 72 Hours to Perihelion. The observation schedule locks on the main screen at NASA's Interstellar Object Tracking Center. It is October 26, 2025. The countdown timer in the corner of the display reads 72 hours, 00 minutes, and 00 seconds. Over the next 3 days, this clock will govern the life of every major observatory on the planet. You watch as the timeline populates, a dense overlapping cascade of telescope assignments, ensuring that from this moment until well after perihelion, 3I Atlas will never be out of sight. On an adjacent monitor, the final thermal models are running. One simulation, labeled Nominal Interstellar Comet, shows what should happen. As the object approaches its closest point to the sun, its surface temperature will spike past the sublimation point of water ice. The animation shows a brilliant coma erupting from the nucleus, followed by the formation of a sweeping dust and ion tail. This is the baseline, the pass condition, for nature's test. This is what 2I Borisov did. Then the operator runs the second model, labeled Anomalous Object Signature. It's based on the handful of puzzling observations already collected, and on the lingering ghost of Oumuamua. In this simulation, the object heats up, its temperature rising, but nothing else happens. It remains a stark, inert point of light. It continues to accelerate slightly, but without any visible cause. This is the fail condition. For months, the global astronomical community has been preparing for this moment. This isn't a surprise encounter like Oumuamua, detected as it was already leaving. The advance warning for 3I Atlas allowed for an unprecedented mobilization. The James Webb Space Telescope has cleared its schedule. The Very Large Telescope Array in Chile and the Keck Observatory in Hawaii are coordinating their observations. Radio telescopes from the VLA in New Mexico to ALMA in the Atacama are prepared to listen for any signature, any clue. The stakes feel immense. After the unresolved controversy of Oumuamua, the scientific community has its reputation on the line. Mainstream astronomy has staked its credibility on the explanation that these visitors are natural, if exotic, comets. 3I Atlas is the tiebreaker. It will either vindicate that position, proving Oumuamua was a one-off peculiarity, or it will confirm a pattern of anomalies that can no longer be easily dismissed. The predictions are made, the instruments are calibrated, the global network of eyes is focused on a single inbound traveler from the stars. All that is left is to watch as the countdown clock ticks towards zero and the sun performs the one experiment humanity cannot. Chapter 5, Part 2, Inside the Solar Observatory. The composite solar data feed flickers on Monitor 3 at NASA's Parker Solar Probe Mission Operations Center. It is 23:17 UTC on October 30th, more than a day after 3I Atlas survived perihelion. Here the focus is not on the object itself, but on the invisible sea it's swimming through. the solar wind. Your attention is fixed on a 3D visualization of the inner solar system, mapping the flow of charged particles from the sun. Solar wind velocity at target location, 450 kilometers per second, the system announces. Data from a fleet of heliophysics spacecraft, Parker, Solar Orbiter, Stereo, is combined to create a precise model of the environment 3I Atlas is currently experiencing. It is a torrent of protons and electrons, an interplanetary gale that should be having a dramatic effect. On the screen, a simulation shows how a normal comet's outgassed material would be ionized by this wind, sculpted into a glowing ion tail stretching for millions of kilometers. But when the simulation is replaced by real-time magnetometer data, there is no tail. There is no large-scale disruption of the solar wind. The space behind 3I Atlas is electromagnetically quiet. Then, a new alert flags something even stranger. The model shows the interplanetary magnetic field lines, which are carried along with the solar wind, draping around the object. But they are not draping in the way they would around an inert rock. The pattern of deflection suggests 3I Atlas may be generating its own weak, localized magnetic field, a magnetosphere. This is an extraordinary property for a comet which are not supposed to have the molten metallic cores necessary to generate a magnetic dynamo. Right now, as you watch this unfold, teams of solar physicists around the world are seeing the same data. The Perihelion test is no longer just about heat and light, it's about the fundamental forces governing the solar system. 3I Atlas is being subjected to a test of electromagnetism, and it is failing in a way that suggests it possesses properties no comet should have. The object is not just passively surviving its journey, it is actively interacting with its environment in a way that is profoundly anomalous. It's behaving less like a chunk of ice and rock, and more like a solid, conductive body. A few days from now, the Europa Clipper spacecraft, on its way to Jupiter, is scheduled to fly through the region where this non-existent tail should be. Its particle detectors and magnetometers will provide the first-ever direct in-situ sampling of the wake of an interstellar visitor. But the data arriving now already paints a stark picture. This object is not just a passive traveler. It is pushing back against the sun's invisible force field. Chapter 6, Part 1, Decoding the Spectrum with James Webb. The infrared spectrum unfolds like a chemical fingerprint across your monitor at the Space Telescope Science Institute. It is 0213 UTC on October 31st, nearly 2 days after 3I Atlas passed perihelion. The data is from the James Webb Space Telescope, which has just completed its most detailed spectroscopic observation yet, capturing infrared light that traveled for 15 minutes across 205 million kilometers of space to reach its golden mirrors. This is the moment of truth for the object's composition. Webb's Near-Infrared Spectrograph, or NIR-SPEC, is humanity's most powerful tool for detecting the subtle chemical signatures of distant worlds. Right now, it is performing the ultimate chemical analysis on this interstellar visitor. The spectrum resolves into a landscape of lines and curves, but the features that should be there, the grand valleys and peaks of a comet's song, are missing. At 2.7 and 3.1 microns on the graph, where the presence of water vapor should carve deep absorption bands, the line is flat. At 4.3 microns, the telltale signature of carbon dioxide is absent. At 3.3 microns, where methane should be screaming its presence, there is only silence. Every volatile compound that should be boiling off the surface of a sun-baked comet is nowhere to be found. Run the Borisov reference spectrum, someone says. A second graph appears below the first. The contrast is breathtaking. The spectrum of 2I Borisov, the interstellar comet from 2019, is rich with the signatures of water, carbon dioxide, and complex organic molecules. It is the spectrum of a living, breathing comet. The spectrum of 3I Atlas is that of a dead rock, or something else entirely. Instead of the signatures of ice, Webb is detecting the faint, unusual emission lines of metallic compounds. The nickel vapor seen from Earth is there, but now Webb adds traces of what appear to be titanium and aluminum alloys glowing faintly in the infrared. The reflectance profile of the object's surface looks less like rock and more like manufactured metal. The perihelion test was supposed to reveal a heart of ice. Instead, the most powerful infrared eye humanity has ever built has peered into the soul of this object and found metal and silence. The absence of water is the most damning piece of evidence yet. Natural explanations are now pushed to the breaking point. An object can't accelerate like a comet while having the chemical signature of an asteroid made of materials not found in asteroids. The contradictions are becoming too great to reconcile. To Chapter 6, Part 2, The Unexpected Water Vapor Signature. A new spectral line appears on the graph at 0724 UTC on October 31st. You stare at the monitor in the James Webb Operations Center as the data refreshes. A sharp, impossibly clean spike suddenly rising from the flat baseline at the 2.7 micron wavelength. For nearly 2 full days since perihelion, this region of the spectrum has been silent. Now it is screaming. It is the unmistakable signature of water vapor. This shouldn't be happening. Water vapor detection confirmed, a voice says over the comms, laced with a tension that cuts through the quiet hum of the control room. Signal strength is increasing. If this were a natural comet, the water signature should have appeared days ago, peaking in a chaotic surge at perihelion as the sun's heat boiled its icy surface. It should not be appearing now, 44 hours late, in a sudden controlled burst. Right now, as you watch, a priority alert flashes from the European Southern Observatory in Chile. Their ground-based, very large telescope, its spectrograph locked on the same target, is detecting the exact same signal. This is not an instrument glitch. It is real. Webb's powerful optics are tasked with resolving the source of the emission. The image that slowly builds on the screen is extraordinary. The water vapor is not erupting from all over the surface, creating a diffuse coma. It is emanating from a single precise point, a localized plume venting directly into space. It looks less like sublimation and more like a thruster. Could it be an impact? Someone asks. A micrometeoroid strike? The data says no. The spectrum is clean. There is no signature of dust or silicate fragments that would have been kicked up by an impact. And the thermal analysis of the vapor itself is even stranger. It's emerging at a temperature consistent with the boiling point of liquid water, not the frigid process of ice sublimating in a vacuum. The natural origins advocates are at a loss. There is no conventional model of cometary physics that can explain this. A delayed, localized cryovolcanic eruption? Perhaps, but for it to occur so long after maximum heating and to produce a plume of pure water vapor with no other volatiles strains credulity to the breaking point. For the anomaly investigators, however, this is the smoking gun, a controlled directional release of propellant, a venting of reaction mass. This observation fits the model of a technological object far better than it fits the model of a natural one. The perihelion test was supposed to be the final exam, the crucible that revealed the object's simple, icy heart. Instead, it has produced a series of contradictions that are pushing the boundaries of known science. And now this, an impossible plume of water, appearing as if on a schedule from a visitor that was supposed to have no water at all. Chapter 7, Part 1, Measuring the Post-Perihelion Velocity. The desert outside the Very Large Array control room is bathed in the cool morning light of November 1st. It is 09:45 UTC, 3 days after perihelion. Inside, you watch as 27 massive radio antennas spread across miles of New Mexico landscape move in perfect unison, tracking a single point in the sky. They are not taking a picture. They are performing astrometry, listening to the object's faint radio signature and triangulating its position with a precision optical telescopes can only dream of. From these measurements, they can calculate its velocity. A new number appears on the main screen, replacing the last update. 42.5 kilometers per second. A quiet intake of breath sweeps through the room. Orbital mechanics are not a matter of debate, they are a matter of mathematics. At this specific distance from the sun, on its current trajectory, an inert object should be traveling at 39 kilometers per second. The discrepancy, a full 3.5 kilometers per second of excess velocity, is not a measurement error. It is a ghost in the machine of orbital mechanics. The immediate question is obvious. Is this acceleration the result of that bizarre, delayed plume of water vapor detected by James Webb? The calculations appear on an adjacent screen almost before the question is fully formed. The answer is a stark, unequivocal no. The amount of mass expelled as water vapor was orders of magnitude too small to produce this much thrust. And even more telling, the acceleration being measured by the VLA is perfectly smooth, constant, and ongoing. It is not the sputtering, uneven push you would expect from a single localized jet. This is the Oumuamua problem, but with a terrifying new clarity. The unexplained acceleration is not a momentary anomaly. It is a continuous, sustained force. Right now, as we speak, the VLA is locked on target. Its data streaming in real time to astronomical centers worldwide. Every 6 minutes it generates a new position, a new velocity, and each new measurement confirms the last. The object is being pushed. The natural origins camp is now forced to argue for a perfectly isotropic, perfectly uniform outgassing of a substance that remains completely invisible to all our instruments, including Webb. A substance that can provide a smooth, continuous thrust. The explanation becomes more strained, more exotic, than the observation itself. The sun's test was supposed to reveal a comet. Instead, it has revealed a paradox. An object that is being propelled through our solar system by an invisible, silent engine, accelerating away from our star on a trajectory that defies the elegant laws of gravity. Chapter 7, Part 2, The Push That Gravity Can't Explain. Inside the Orbital Mechanics Unit at the Jet Propulsion Laboratory, the mood is one of intense, frustrated concentration. It is 18:07 UTC on November 1st. The latest velocity data from the Very Large Array is on the main screen, a series of data points that form a stubbornly straight line of acceleration. For 3 days, physicists have been trying to model the force that is pushing 3I Atlas. Every conventional model has failed. You watch as an engineer runs the outgassing simulation for the 10th time. He models the small localized plume of water vapor detected by James Webb. On the screen, the resulting trajectory barely nudges the object from its purely gravitational path. The thrust is a tiny fraction of what is needed to explain the observed acceleration. He then models a hypothetical continuous jet of the same size. Still not enough. To match the observed velocity, the object would have to be expelling a significant percentage of its mass, which would be blindingly obvious to every telescope on Earth. The outgassing model is a dead end. Run the solar radiation pressure model, the lead physicist says, his voice resigned. This is the last resort, the most controversial explanation. Solar radiation pressure is the gentle push exerted by photons of light from the sun. For a large, massive object, this force is negligible. But if an object has a very large surface area and a very low mass, if it is incredibly thin, this gentle push can become significant. The engineer inputs the object's known size and its observed acceleration. The computer calculates the mass and density required for solar radiation pressure to be the driving force. The numbers that appear on the screen are the reason this hypothesis is so controversial. For this to work, 3I Atlas would have to be less than a millimeter thick. It would have to be, for all intents and purposes, a solar sail. A profound silence hangs in the room. This is the exact same conclusion that Harvard astronomer Avi Loeb reached for Oumuamua in 2017, an explanation that was widely dismissed by the mainstream astronomical community. Now faced with even clearer data from a second object, that same extraordinary possibility is the only one that fits the math. The Perihelion test has backed the scientific community into a corner. Either 3I Atlas is being propelled by a form of outgassing from a material that is invisible and provides a perfectly smooth, continuous thrust, a process that violates known physics, or it is being pushed by the light of our own sun, which would imply that it is an object of incredibly low density and large surface area. It implies technology. Right now, as 3I Atlas continues to accelerate away, NASA's Europa Clipper spacecraft is adjusting its course slightly. In 4 days, it will fly directly through the object's wake. Its instruments, designed to study the faint atmosphere of a Jovian moon, will become humanity's first interstellar probe, directly sampling the space behind this visitor. They will search for the invisible propellant that must be there if this is a natural object, and if they find nothing, the implications are staggering. Chapter 8, Part 1. What the Mars Orbiters Saw. The data packet arrives at JPL Mission Control in Pasadena with a timestamp of 04:55 UTC, November the 2nd. It is raw imaging data from MRO, the Mars Reconnaissance Orbiter, which has been in orbit around the red planet for nearly 2 decades. By a fortunate coincidence of orbital mechanics, MRO had a direct close-range view of 3I Atlas as it passed through its perihelion, a perspective no Earth-based telescope could achieve. The images are downloaded and processed. A hushed anticipation fills the room. These are the highest resolution photos of the interstellar object that humanity will ever capture. The high-rise camera, designed to photograph the Martian surface in stunning detail, was turned toward the visitor as it passed just 18 million kilometers away. The first image appears on the main screen. It is not a fuzzy comet. It is a sharp, defined object against the black of space. The computer begins its analysis, calculating size, shape, and rotation. The results confirm what the light curve suggested. The object is not a chaotic, tumbling rock. It is a stabilized, rotating body, approximately 1.5 kilometers long and 400 meters wide. But it is the surface detail that commands the room's attention. Even at this distance, high-rise can resolve features down to a few meters. There are no impact craters, no signs of geological activity. The surface is smooth, featureless, and reflects the sunlight with an unnerving uniformity. It has the albedo of polished metal because, from this vantage point, it looks like polished metal. Then, the second image loads. This one was taken 7.8 hours after the first, one full rotation. The object is identical, but something has changed in the space around it. The image shows the faint ethereal plume of water vapor detected by James Webb, venting from a single point on the object's hull. In the MRO image, the plume is not a chaotic cloud. It is a perfectly collimated, focused jet. It looks like the exhaust from an engine. This is a perspective no one expected to have. An eye in the sky, 18 million kilometers away from the object, providing a ringside seat to its impossible behavior. The data confirms and sharpens every anomaly seen from Earth. The precise rotation, the high albedo, the lack of a coma, the extreme structural integrity, and now a visual confirmation of what looks for all the world like a controlled release of propellant. The perihelion test, as seen from Mars, delivers the most unsettling verdict of all. The images from MRO are not ambiguous. They do not leave much room for interpretation. They show an object that does not look or act like anything nature has ever been known to produce. The data is immediately classified pending review. But the handful of scientists in this room have just become witnesses to something that will change the course of human history. Chapter 8, Part 2. When the comet went dark. The alert flashes across every screen in the European Southern Observatory's control room in Garching, Germany, at 11:30 UTC on November 3rd. It's a photometric alert, triggered automatically when an object's brightness deviates from its predicted light curve by more than 5 sigma, a statistical impossibility. On the main display, the perfect clockwork sine wave of 3I Atlas's light curve, which has been holding steady for 5 days, suddenly plunges. It hasn't just dimmed, it has fallen off a cliff in the space of less than 10 minutes. The object's baseline magnitude has dropped by a factor of 15. Frantic commands are entered. Spectrographs on the Very Large Telescope in Chile, which was observing at the time, are tasked to analyze the change. Radar pings are sent from Goldstone. Every available instrument is retasked to understand what has just happened. The data that comes back is more baffling than the event itself. The object hasn't fragmented. High-resolution imaging shows it is still intact, its shape unchanged. Its trajectory is also unaltered. The smooth, non-gravitational acceleration continues exactly as before. And most perplexing of all, there is no debris cloud, no expanding halo of dust or gas. A natural comet shedding its bright outer layer would have created a spectacular dusty nebula. This object has simply changed color. The albedo calculations are run again. The number that returns is 0.05. It has gone from reflecting 74% of the sun's light to reflecting just 5%, from a mirror to a lump of coal. The transition was swift, clean, and total. For the natural origins camp, this is a moment of profound crisis. There is no known physical process that can account for such a rapid, uniform, and debris-free change in a celestial body's surface properties. It is as if the object simply decided to become dark. But for the anomaly investigators, this is the final definitive piece of the puzzle. The object is not passive, it is active. They argue this is not a geological or chemical process, it is an operational one, a change in state. Perhaps a retraction of reflective surfaces now that the intense heat of perihelion is over. A shift from a thermal regulation mode for surviving the inner solar system to a stealth mode for its long journey back to the interstellar dark. Right now, as the observation window enters its final days, the global astronomical community is staring at the data in stunned silence. The perihelion test is over, and the verdict is that 3I Atlas has not just failed the test for being a comet, it has begun to exhibit behaviors that look less like passive physics and more like active engineering. The Europa Clipper spacecraft is now just 2 days from its flyby of the object's wake. The stakes for what its instruments will or will not find have just become monumental. Chapter 9, Part 1, A Trajectory That Shouldn't Exist. The orbital plot on the main screen at JPL isn't showing speed or acceleration, it's showing geometry. It is 22:10 UTC on November 4th. And you are looking at the solar system from the side, a flattened disk of planetary orbits called the ecliptic plane. On this display, the paths of Mercury, Venus, Earth, and Mars are thin concentric lines. You then watch as the computer plots the hyperbolic arc of 3I Atlas. It is a clean, swift line slicing through the system, and it is almost perfectly flat. Orbital inclination relative to the ecliptic, 0.8 degrees, the system announces. The number is so small, it's almost unbelievable. Interstellar space is a 3-dimensional sphere. An object arriving from another star, flung out by some chaotic gravitational event, should arrive from a random direction, from high above the solar system or far below, at any conceivable angle. The ecliptic plane is an infinitesimally thin target in a cosmic shooting gallery. For a random visitor to arrive on a path so perfectly aligned with the plane of the planets is statistically miraculous. Run the probability analysis, the lead dynamicist requests. The computer crunches the numbers. The chance of a random interstellar object having an inclination this low is less than 0.1%. Then someone pulls up the orbital data for the previous two visitors. 2I Borisov, the normal comet, came screaming in at a steep 44-degree angle, a truly random chaotic entry, exactly as expected. But Oumuamua, the first anomaly, also had a suspiciously low inclination. Not as low as this, but low enough to be statistically notable. Right now, as you stare at the screen, the implications are profound. This isn't just about the object's composition or its unexplained acceleration anymore. This is about its path. A path of mathematical convenience, a trajectory that brings it sweeping past the inner rocky planets in a way that would be remarkably efficient for observation. To most astronomers, it is a baffling, almost impossible coincidence, a 1 in 1,000 chance that just happened to occur. But for others, including a growing number of researchers who have remained silent until now, the word coincidence is becoming a difficult explanation to accept. Twice now, an anomalous interstellar object has arrived on a statistically improbable trajectory. The Perihelion test was about physics and chemistry, but this final lingering piece of evidence is about geometry, about the simple, elegant line the object has drawn through our solar system, a line that looks less and less like the product of random chance, and more like a path chosen with intent. Chapter 9, Part 2. At the Very Large Telescope. The night is cold and clear over the Atacama Desert. Inside the control room of the European Southern Observatory's Very Large Telescope, you are not looking at an image or a spectrum. The data on your screen is a vector plot, a swirl of tiny lines showing the orientation of light waves that have traveled for 17 minutes from 3I Atlas to this remote mountain in Chile. This is polarimetry, and it is the most intimate look yet at the texture of the object's surface. Sunlight is a chaotic jumble of unpolarized light waves. When those waves reflect off a surface, they become partially polarized, aligned in a direction that reveals the nature of that surface. A rough, dusty, porous surface, like that of every comet ever studied, scatters light in all directions, producing a very low degree of polarization, typically under 5%. The number that has just been calculated from the VLT's Force 2 instrument is 22%. The measurement is so high, it is rechecked against every calibration star in the field. There is no error. The light reflecting off 3I Atlas is highly organized. This is not the signature of a dusty ice ball. It is the signature of a smooth, uniform surface, something that reflects light with the precision of a mirror or a finely machined solid. This data powerfully corroborates the albedo measurements from days earlier. An object that is highly reflective should also be highly polarizing if its surface is smooth, and it is, but then the team runs the analysis on data taken just after the mysterious darkening event. The polarization has dropped, but not to the level of a comet. It has settled at around 8%, still too high for a natural dusty body, but consistent with a surface that has changed from something polished to something more matted or perhaps coated. Right now, as we speak, astronomers are watching this data in real time. The object has not just changed its brightness, it has fundamentally altered the texture of its surface in a way that is uniform across the entire body. The Perihelion test has pushed this visitor to reveal its secrets, and the secrets are becoming more and more difficult to explain with natural physics. The light from 3I Atlas is not just reflected, it is organized. The photons arriving in the stark, dry air of the Atacama carry an imprint of a surface that has no known analog among the natural bodies of our solar system. With each new test, the object seems less like a piece of cosmic debris and more like something designed. Chapter 10, Part 1, A Ghost of Oumuamua. At the Harvard-Smithsonian Center for Astrophysics, the raw data from the Global Observation Campaign is being collated into a single comprehensive file. It is 14 hours UTC on November 5th. The perihelion test is over, the verdict is in, and now the true analysis begins. You are looking at a comparative plot, a stark side-by-side juxtaposition of the known properties of the three interstellar visitors humanity has so far encountered. Column 1. Oumuamua, discovered 2017, anomalous acceleration, no visible outgassing, high albedo, chaotic, tumbling rotation. The dataset is frustratingly incomplete, a ghost in the machine. Column 2, 2I Borisov, discovered 2019, a textbook natural comet. Its acceleration was perfectly explained by its massive visible coma and tail. Its albedo was low. Its spectroscopy showed the expected water and carbon compounds. It was the control group, the proof that nature does in fact throw snowballs between the stars. And then there is column 3, 3I Atlas. You watch as the data points fill the column, each one a nail in the coffin of the natural comet hypothesis. The acceleration is there, just as with Oumuamua, but this time it is measured with exquisite precision. The lack of outgassing is confirmed not just by optical telescopes, but by the unparalleled infrared eye of James Webb. The high albedo is not an estimate. It is a confirmed measurement that changed in real time. The rotation is not chaotic, it is a clockwork, stabilized spin. The similarities to Oumuamua are not just suggestive, they are systematic, but where Oumuamua's data was sparse, 3I Atlas's is a flood. It is Oumuamua's ghost, returned not as a fleeting shadow, but as a high-resolution photograph. Right now, as we speak, this is the table that is forcing a quiet, urgent panic within the astronomical community. A single anomaly can be dismissed as a fluke, a one-in-a-million natural object with strange properties, but two objects, arriving just 8 years apart, both exhibiting a nearly identical suite of characteristics that defy natural explanation, the odds of that being a coincidence are themselves astronomical. The Perihelion test of 3I Atlas was supposed to be the tiebreaker, the event that would prove Oumuamua was the exception and Borisov was the rule. Instead, it has established a class of objects. It has confirmed a pattern. The ghost of Oumuamua no longer stands alone. It now has a companion, a sibling, a second data point that transforms a mystery into a statistical population. The question is no longer, what was Oumuamua? The question now is, what are these things, and how many more are on their way? Chapter 10, Part 2, The Opposite of Borisov. You're looking at a split screen. On the left, an animation reconstructs the 2019 passage of 2I Borisov, the second interstellar visitor. It is a textbook comet. As it nears the sun, it erupts in a glorious, chaotic display of outgassing. A vast, hazy coma of water vapor and dust expands around it. Its trajectory is nudged slightly by these unpredictable jets. Its spectrum is rich with the chemical fingerprints of life's building blocks, water, carbon monoxide, complex organics. Borisov was a reassuring visitor. It proved that interstellar space is full of the same kind of natural debris that litters our own solar system. It was the safe, predictable answer. On the right side of the screen, the data for 3I Atlas is being plotted in real time. And it is the mirror opposite of Borisov in every single respect. Where Borisov was chaotic, Atlas is ordered. Its rotation is a perfect, stable sine wave. Its trajectory is a smooth, continuous acceleration. Where Borisov was dirty, Atlas is clean. Its surface is highly reflective, not the dark, sooty black of a typical comet. Its spectrum is devoid of the organic chemistry that defined Borisov. It shows only the strange, clean signature of metallic vapor. Where Borisov was active, Atlas is passive, until it isn't. Borisov's outgassing began far from the sun and peaked at perihelion, as physics demands. Atlas remained inert through the worst of the heat, only to later emit a focused, controlled plume of pure water vapor on a schedule that defies any natural explanation. Right now, as we speak, the full weight of this comparison is settling upon the astronomical world. 3I Atlas was the tiebreaker. It was supposed to confirm that Borisov was the rule and Oumuamua was the fluke. Instead, it has done the opposite. It has shown that Borisov may be the exception, the one boring, predictable visitor in a gallery of profound strangeness. The perihelion test for 3I Atlas has become an exercise in inversion. Every test that a natural comet should pass, it has failed. And every failure points not to a new, exotic class of natural object, but to a set of properties that are difficult to describe with any word other than artificial. The data no longer allows for easy explanations. The problem is no longer a single anomalous object. The problem is a pattern. Two objects, Oumuamua and Atlas, that are the opposite of Borisov. The solar system is not just being visited by random rocks from other stars. It appears to be encountering something else entirely, and we have no idea what that is. Chapter 11, Part 1, The Oberth Maneuver Question. In the mission analysis room at JPL, a small team of propulsion engineers is looking at the data from 3I Atlas not as astronomers but as rocket scientists. It is 1904 UTC, November 5th. On their screens, the velocity data is plotted against the object's distance from the sun. What they are looking for is not just the acceleration, but its timing. The peak thrust occurs precisely at perihelion, the lead engineer states, pointing at the apex of the curve. That's not outgassing, that's an Oberth maneuver. The Oberth effect is a fundamental principle of rocket science. It states that a propulsion system is most efficient at converting fuel into kinetic energy when it is operating at its highest speed, at the lowest point of its gravitational orbit. Every interplanetary probe humanity has ever launched uses this principle, firing its engines at closest approach to a planet or the Sun to gain the maximum possible change in velocity. It is the single most efficient way to travel through a solar system. Natural comets do not perform Oberth maneuvers. Their outgassing is a function of heat, which peaks at perihelion, but the resulting acceleration is messy, chaotic, and often continues for days or weeks after closest approach. It is not a clean, efficient burn timed for maximum effect. But the acceleration curve of 3I Atlas is clean. It shows a smooth, powerful push that began just before perihelion, peaked at the exact moment of closest approach, and then tapered off with perfect symmetry. It has the profile of an engine burn, and then there is the matter of the water vapor. It was detected 44 hours after perihelion, long after the main acceleration phase was over. The engineers in this room are now discussing a radical possibility. The main acceleration was not caused by the water vapor. The water vapor was something else, perhaps a small secondary course correction or a venting of waste heat. The primary acceleration remains unaccounted for by any visible means. It was a silent, powerful push, timed with a precision that seems less like a random act of nature and more like a deliberate, calculated maneuver. Right now, as this data is being analyzed, the line between astronomy and engineering is beginning to blur. The behavior of 3I Atlas is being described in terms of specific impulse and delta V. The questions being asked are no longer just about its composition, but about its design. The perihelion test, which was meant to reveal the object's geology, is instead revealing what looks unnervingly like a masterclass in orbital mechanics. The object didn't just survive its encounter with the Sun, it used it. Chapter 11, Part 2, Modeling the Impossible Trajectory in a Secure Briefing Room at NASA Headquarters. The trajectory is undeniable. It hangs on the main screen, a smooth, impossible curve plotted from the combined radar and optical data of the last 7 days. It is 20:30 UTC on November 5th. The most senior administrators are here, staring at the same data the astrodynamics team has been wrestling with for a week. The panic is quiet, professional, and absolute. You watch as the head of the modeling team walks them through the findings. The screen splits into 3 panels. On the left, the observed trajectory of 3I Atlas. In the middle, the best fit model for outgassing. To achieve the observed delta V of nearly 9 kilometers per second, the simulation shows the object would have had to shed almost a third of its estimated mass in a continuous, perfectly focused jet. It would have created a coma so vast and bright, it would be visible with amateur binoculars. The model is a spectacular failure. On the right, the solar radiation pressure model. This is the last desperate hope for a natural explanation. For the gentle push of sunlight to account for the acceleration, the object must have an extremely low mass-to-area ratio. The engineer brings up the final damning calculation. For this model to work, 3I Atlas, an object over a kilometer long, would have to have a total mass of less than a few metric tons. Its density would be thousands of times less than the air in the room you are standing in. It would have to be an impossibly thin, perfectly reflective solar sail. The briefing concludes, there are no natural models that fit the data, not a single one. Every attempt to explain the object's behavior through the lens of known physics results in a physical absurdity. This is the moment the institutional panic sets in. The problem is no longer just a scientific mystery, it is a crisis of communication. For 8 years since Oumuamua, the official position has been that these are natural, if unusual, objects. That position is now completely untenable, destroyed by a week of irrefutable data. The perihelion test, which was supposed to confirm the natural explanation, has systematically dismantled it piece by piece. The question hanging in the air is no longer what is it, but what do we say? Right now, as the meeting concludes in stunned silence, a single hope for a conventional explanation remains. 200 million kilometers away, the Europa Clipper spacecraft is closing in on the object's wake. It is less than 24 hours from its fly-through. Its particle detectors are on, its magnetometers are active. It is about to fly through the space where the invisible propellant from this impossible engine must be. If it detects nothing, the last bastion of natural explanation will fall. Chapter 12, Part 1, Inside the Planetary Science Division. The silence in the conference room at NASA's Planetary Science Division is heavier than gravity. It is 01 ZAO UTC, November 6th. For the past hour, you have been sitting here, watching the division directors stare at the summary screen. It is a simple, brutal checklist of the perihelion test results for 3I Atlas. Every single item flagged in red. This is no longer a real-time data feed from a telescope. This is the after-action report. The post-mortem on a paradigm. The director points a finger at the screen, her voice low and steady. So, to be clear, she begins, it survived perihelion without any structural degradation. It failed to outgas when physics demanded it. It then produced a focused plume of pure water vapor on a schedule that makes no sense. It is accelerating under a force we cannot identify in a manner consistent with an engine burn. It has changed its surface properties from highly reflective to highly absorbent in minutes, and it arrived on a trajectory with a statistical probability of less than 0.1%. Is that a fair summary? There are only nods in response. This is the moment of institutional panic. Not the wild, chaotic panic of a disaster movie, but the cold, quiet dread of a scientific body that has run out of road. For 8 years, since Oumuamua, the official reputation-staked position of NASA and mainstream astronomy has been that these objects are natural. Exotic, perhaps. Strange, certainly, but natural. 2I Borisov was the great relief, the data point that seemed to prove it. But the data from 3I Atlas has systematically, brutally, and publicly dismantled that entire framework. The data is too clear, the observation campaign too comprehensive, the anomalies too numerous and self-consistent to be explained away this time. The intellectual framework for explaining these visitors has collapsed, in real time, in front of the entire world. Right now, the pressure is immense, the data is global. Thousands of astronomers have seen it. The first papers from independent researchers are already hitting the preprint servers. The question for the people in this room is no longer a scientific one. It is a question of policy, of disclosure. How does NASA, the institution, stand before the world and say, we have just observed an object in our solar system that exhibits multiple independent lines of evidence consistent with non-natural technological origins? The final hope for a conventional explanation is now just hours away. The Europa Clipper spacecraft is closing in on the object's wake. The command sequence has been sent. Its instruments will soon taste the void behind 3I Atlas. If they find a rich trail of exotic, invisible particles, the propellant of some unknown natural engine, then science can breathe again. But if they find nothing, if the space behind this accelerating object is as empty as it appears, then there will be nowhere left to hide. Chapter 12, Part 2, Debunking the Nitrogen Iceberg. A new paper appears on the Astrophysics preprint server at 04:15 UTC, November 6th. It's an emergency publication from a team of planetary scientists, a last-ditch effort to salvage a natural explanation for 3I Atlas. You read the abstract. The hypothesis is elegant, desperate, and hinges on a single exotic idea that 3I Atlas is not a comet, but a massive shard of solid nitrogen ice. The theory is compelling because it solves several problems at once. Nitrogen ice is highly reflective, which would explain the object's high albedo. As it sublimates under solar heat, it would create a transparent, invisible gas, potentially explaining the acceleration without a visible coma. And these nitrogen icebergs are thought to be knocked off the surfaces of Pluto-like worlds in other solar systems. It is the most plausible natural explanation left on the table. But the paper was written before the latest data came in, and right now, as you sit in the control room, that data is actively dismantling the hypothesis in real time. You look at the latest spectral analysis from James Webb to sublimate with enough force to cause the observed acceleration. The nitrogen gas would have to be heated by the sun. As it heats, it would glow at a specific infrared wavelength. Webb has been staring at that exact wavelength for a week. The spectrum is flat. There is no nitrogen. You look at the structural analysis from the adaptive optics teams at Keck and the VLT. A nitrogen iceberg, being a giant brittle chunk of frozen gas, would be incredibly fragile. The thermal shock of perihelion should have shattered it into a million pieces, but 3I Atlas is structurally perfect. And finally, you look at the temperature data. Nitrogen sublimates at an extremely low temperature. A nitrogen iceberg would have begun outgassing furiously long before it reached the inner solar system, far out past the orbit of Saturn. But 3I Atlas remained completely inert until its bizarre, localized water plume long after perihelion. The nitrogen iceberg hypothesis, the last best hope for a conventional answer, has been destroyed by the very data it was proposed to explain. The perihelion test was not just a test of the object, it was a test of our theories, and one by one, every natural theory has failed. The object is not made of water ice, it is not made of hydrogen ice, and now it is demonstrably not made of nitrogen ice. The silence in the control room is the sound of an entire field of science running out of explanations. The observation window is closing, and as 3I Atlas speeds away, it leaves behind a trail not of gas or dust, but of broken theories. All that is left is the stark, unsettling data and the extraordinary conclusion it seems to demand. Chapter 13, Part 1, The Missing Iron Signature. You are in the control room of the Very Large Telescope, high in the Atacama Desert of Chile. It is 1720 UTC, November 6th. The observation window is nearly closed. On your screen is not an image, but a graph of light intensity versus wavelength. The telescope's spectrograph has spent the last 8 hours painstakingly collecting photons from 3I Atlas, splitting them into their constituent colors, and building a definitive chemical profile of the object's surface. A brilliant green-blue line spikes off the chart at 5 and 20 nanometers. This is the nickel vapor, the signature that has been present since before perihelion, now confirmed with overwhelming clarity by the VLT's immense light-gathering power. It is an unusual but not impossible feature for a natural object, but it's the absence of another line that is causing a stir among the spectroscopy team. Nickel and iron are cosmic siblings. They are forged in the fiery hearts of the same dying stars, born from the same supernova explosions that seed the galaxy with heavy elements. In every asteroid, every meteorite, every comet humanity has ever studied, where you find nickel, you find iron. Their ratio varies, but they are always together. The spectrograph is also scanning for iron's signature, a dense cluster of emission lines around 385 nanometers. The instrument sensitivity is more than high enough to detect even trace amounts. But as the data integrates, building a clearer and clearer picture, the line at 385 nanometers remains perfectly unnervingly flat. There is no iron. Run the abundance ratio calculation, the lead astronomer requests. The computer returns an error. It cannot calculate a ratio when one of the values is 0. Right now, as this data is being shared across the global astronomy network, it is presenting a profound challenge not just to planetary science, but to astrophysics. A natural object with a pure nickel signature and no iron is a chemical impossibility. There is no known stellar process that can produce one without the other. To find nickel without iron is like finding a fossilized footprint with no skeleton anywhere on the planet. It implies a process of separation, of refinement, that nature does not perform. The perihelion test was supposed to reveal the object's true nature by heating its surface and releasing its constituent elements. It has done exactly that, and the nature it has revealed is one that seems to violate the fundamental rules of cosmic chemistry. This is no longer just about anomalous acceleration. This is about a chemical composition that, according to our understanding of the universe, simply should not exist. To Chapter 13, Part 2, an isotope ratio from another star, the Atacama Large Millimeter Submillimeter Array, or ALMA, is not a single telescope. It is an army of 66 precision radio antennas spread across the high Chilean desert, working as one. Right now, on November 6th, that entire army is aimed at one target. You are at the ALMA Operations Support Facility, watching as the data from that army is combined and processed by a supercomputer called a correlator. The goal is no longer just to detect the faint water plume from 3I Atlas, but to dissect its very atoms. Every element in the universe comes in different weights, or isotopes. The ratio of these isotopes is a fundamental fingerprint of where that material was formed. Everything in our solar system, the Earth, the asteroids, the comets from the Oort cloud, shares the same basic isotopic ratio of oxygen. It is a chemical signature that says home. Material from another star system should have a different ratio, a different fingerprint. When 2I Borisov passed through, its water showed an isotopic ratio that was clearly alien, but it was still a messy, natural ratio as expected. ALMA is so powerful it can distinguish the faint signal of water made with heavy oxygen 18 from that made with normal oxygen 16. This is the most subtle and perhaps the most definitive test of an object's origin. The results appear on your screen. The team has been integrating the signal for hours, building up a clear reading. The ratio of oxygen 16 to oxygen 18 in the water from 3I Atlas is not just alien, it is perfect. For every 499 molecules of water with normal oxygen, there is exactly one molecule with heavy oxygen. It is a clean integer ratio of 500 to 1. There is no statistical noise, no messy natural variation. Nature does not do this. Isotope separation, the process of sorting atoms by their weight, is an incredibly difficult, energy-intensive industrial process. Humanity uses it to enrich uranium for nuclear reactors. There is no known natural process that can produce isotopically pure water and then assemble it into a kilometer-scale object. The perihelion test has ended with its most profound discovery. It has revealed that the water being vented by 3I Atlas is not just water, it appears to be processed water. Refined water. This is no longer evidence of anomalous geology. This is evidence that looks, for all the world, like industrial chemistry. The final piece of data from the observation window has arrived. It is not ambiguous. It is not open to interpretation. It is a number, and that number suggests that the material being vented by our interstellar visitor was manufactured. The question is no longer, what is it? The question has become, who built it? Chapter 14, Part 1. The data from the radio telescope array. You are in the central control building of the Very Large Array, a cathedral of radio astronomy spread across the high desert plains of New Mexico. It is 08 SAU UTC on November 7th. The critical observation window is in its final hours. For the past 48 hours, all 27 of the VLA's massive 25-meter dishes have been engaged in a single coordinated task. They are not just tracking 3i Atlas's position, they are listening. On the main screen, a waterfall display shows a river of radio frequencies, a visual representation of the cosmic static the antennas are collecting. Most of it is the background hiss of the universe, the faint afterglow of the Big Bang, the roar of distant quasars, the hum of our own galaxy. The powerful correlator computer is designed to sift through this noise, to search for one thing: a pattern, a single narrowband artificial signal, a beacon, a telemetry stream, anything that would betray the presence of technology. This is the most direct test yet. All the other data, the acceleration, the albedo, the composition, are circumstantial evidence. A deliberate radio signal would be proof. It would be the end of all debate. So for 2 full days, humanity's most sensitive radio ear has been pressed against the void, listening to our visitor. The result is displayed in the bottom corner of the screen. Signal-to-noise ratio, 0. There is nothing. Right now, as we speak, similar listening campaigns by radio telescopes across the globe are reporting the same result. The object is utterly, completely silent. It is not broadcasting across any frequency we are capable of monitoring. This silence is, in its own way, as profound an anomaly as any of the others. For the natural origins camp, it is a sign that the object is, after all, just a rock. But for the anomaly investigators, it raises a far more unsettling set of questions. If the object is technological, why is it silent? Is it dormant? Is it deliberately masking its emissions? Or is it communicating in a way that we cannot even conceive of? The Perihelion test has revealed an object that is strong, fast, and impossibly composed. Now, the final test of the observation window reveals that it is also silent. It moves with purpose, but it does not speak. It acts, but it does not announce. The VLA continues its listening campaign, scanning every available band, but the silence holds. The object that has failed every test for being a natural comet has now failed the most basic test for being a simple beacon. It is not a piece of nature as we know it, and if it is a piece of technology, it is not one that is interested in talking to us. It just continues its silent, impossible acceleration, leaving a profound and unsettling quiet in its wake. Chapter 14, Part 2, A Pancake or a Cigar. It's 11 UTC on November 7th. In a data visualization lab, you are looking at the final piece of the observational puzzle, the object's shape. The light curve, with its perfect clockwork variation in brightness, tells us that the object is not spherical. As it rotates, it presents a wider, brighter face than a narrower, dimmer one. The extreme regularity of the curve allows for a precise mathematical inversion, a reconstruction of the object's silhouette. The computer model resolves on the screen. The object is extremely elongated. The ratio of its longest to shortest axis is at least 6:1. This is not the lumpy, potato-like shape of a typical asteroid or comet. This is a radical, extreme geometry. But is it a cigar like Oumuamua was first thought to be, or is it a pancake? The team brings up the polarimetry data from the Very Large Telescope. The way the light is polarized as the object rotates provides the answer. The model updates. The object is not a cigar tumbling end over end. It is a flat circular disc spinning like a coin flipped through space. It is a pancake, and when this shape is fed into the solar radiation pressure model, the final piece of the puzzle clicks into place. A flat, thin object would perfectly explain the smooth, continuous acceleration. It is the ideal shape for a solar sail. The silence that follows this revelation is profound. The Perihelion test is now complete. Every single observation, from the object's initial composition to its thermal resilience, its acceleration, its late-stage activity, its sudden change in color, and now its geometry, points away from a natural explanation and towards a technological one. Right now, as this model is being triple-checked by independent teams around the world, the scientific community is confronting the data. For the natural origins advocates, the chain of coincidences has become too long to bear. For the object to be a natural comet, it would have to be a new kind of comet, made of an unknown material, with an impossible chemical signature, an impossible shape, an impossible trajectory, that performs an impossible maneuver and just happens to look and act exactly like a piece of advanced technology. For the anomaly investigators, there is no coincidence at all. It looks like a solar sail because that is what it is. The weight of the evidence is now so overwhelming that the debate is shifting. The question is no longer whether it is natural or artificial. The question now being whispered in the halls of NASA and ESA is, what do we do with this information? The final, definitive piece of data is now just hours away as the Europa Clipper spacecraft makes its final approach to the object's wake. The truth is no longer being written in photons. It is about to be touched. Chapter 15, Part 1, The Razor of William of Ockham. The whiteboard in the astrophysics department is a tapestry of failed theories. You stand before it, looking at the list of explanations that have been proposed and systematically disproven over the last 10 days: a nitrogen iceberg, a hydrogen iceberg, a cometary fragment swarm, an object with a bizarrely thick, non-volatile crust. Each theory has been cut down by the relentless flow of data from the Perihelion test. This is the moment when science turns to a 14th-century Franciscan friar named William of Ockham. His principle, known as Occam's razor, is the foundation of the scientific method. It states that when faced with competing explanations for a phenomenon, the simplest one, the one that requires the fewest new assumptions, is the most likely to be correct. Right now, as you look at the whiteboard, you see the consequences of ignoring this principle. To explain 3I Atlas as a natural object, you must now invoke a whole chain of extraordinary and, in some cases, physically impossible assumptions. You must assume the existence of a new class of comet, made of a material never before seen. You must assume this material is strong enough to survive perihelion, but also able to produce a powerful, invisible, and perfectly continuous thrust. You must assume it is highly reflective and can change its reflectivity in minutes without producing debris. You must assume it can be made of pure nickel without iron, a violation of astrophysics. You must assume it can vent isotopically pure water. And you must assume that this impossible object just happened to arrive on a 1-in-1,000 trajectory. This is not a simple explanation. It is a convoluted, self-contradictory tower of ad hoc hypotheses, each one invented to explain away a single inconvenient fact. Then you look at the other explanation, the one that no one in the room wants to write on the board, the hypothesis of artificial origin. And you realize that Occam's razor is now pointing in a terrifying new direction. The artificial hypothesis requires only one assumption, that another technological civilization exists, or once existed, in the galaxy. From that single assumption, everything else follows. A technological object would be strong. It could have a propulsion system. It could have a reflective hull. It could be made of refined materials. It could vent processed water. It could change its surface properties. And it could arrive on a precise trajectory. The simplest explanation is no longer the natural one. The simplest explanation, the one that accounts for all the data with the fewest new assumptions, is that 3I Atlas is not a comet. It is a probe. The Perihelion test has applied Occam's razor to this interstellar visitor, and the blade has cut away every last shred of natural explanation, leaving only the stark, extraordinary, and now simplest conclusion. Chapter 15, Part 2. What Avi Loeb sees in the data. A video call connects you to the office of Harvard astrophysicist Avi Loeb. He has become the reluctant public face of the anomaly investigation camp, the one scientist willing to publicly state what many are now privately concluding. He is looking at the same data you are, the same final report from the Perihelion test. His face is calm, but his words are carefully chosen, each one landing with the weight of scientific revolution. The data from 3I Atlas is a vindication of the scientific method. He begins. When we saw the anomalies of Oumuamua in 2017, I proposed that we must consider the possibility of an artificial origin. This was not a belief, it was a testable hypothesis. The mainstream response was to invent a series of ever more exotic natural explanations, a hydrogen iceberg, a nitrogen iceberg, theories that required us to imagine new kinds of objects for which we have no evidence, just to avoid a single, simpler conclusion. He pulls up the comparative data on his screen. Science progresses by investigating anomalies, not by dismissing them. What 3I Atlas has done is provide a second high-quality data point. The argument is no longer about one strange object, it is about a population of strange objects. Look here, he says, pointing to the acceleration curve. This is not a chaotic, sputtering outgassing. This is a clean, efficient, sustained acceleration that peaked at perihelion. It is a textbook Oberth maneuver. To explain this naturally, you must invent new physics. To explain it as technology, you need only the physics we have been using for 60 years to send our own probes to the planets. He switches to the chemical analysis. And the composition, nickel without iron, isotopically pure water, these are not the signatures of a star's forge. These are the signatures of a refinery, of industrial processing. He leans forward, his gaze intense. We must now apply Occam's razor. What is the simpler explanation? That nature has conspired to create a new class of object that perfectly mimics the characteristics of a solar sail, down to its composition, its maneuverability, and its trajectory, or that we are seeing what we are seeing, a piece of technology from another civilization? The data from the Perihelion test has answered the question. He concludes, 3I Atlas did not fail the test for being a comet. It passed with perfect marks the test for being a probe. The reluctance of the mainstream to accept this is no longer a scientific position, it is a psychological one, a failure of imagination. The data is speaking. We have only to listen. Chapter 16, Part 1, An Emissary from the Galactic Thick Disk. The trajectory of 3I Atlas is being run backwards in time. On the main screen at the Gaia Data Processing Center in Germany, a supercomputer is taking the object's precise velocity and direction, now known to an unprecedented degree of accuracy, and rewinding its journey, star by star, millennium by millennium, back into the interstellar void. This is the final act of the observation campaign. To find out where it came from, the glowing line of its past journey stretches back past Alpha Centauri, past the local stellar neighborhood, past the point where any random cometary ejection could have occurred. The line continues, unswerving, for thousands of light years, and it does not originate from where it should. Our sun and all our neighboring stars belong to the galactic thin disk, a dense, flat, rapidly rotating plane of stars rich in heavy elements. This is where most of the galaxy's life is expected to form, but the line of origin for 3I Atlas doesn't resolve in the thin disk. It comes from above, from the galactic thick disk, a sparse, puffy halo of ancient stars that orbit the galactic center on slower, more eccentric paths. This was supposed to be the key, the final piece of context that might offer a natural explanation. Instead, it provides a paradox. Thick disk stars are ancient. They are among the first generations of stars to form in the Milky Way. As such, they are metal poor. They formed from a universe that had not yet had time to cook up heavy elements in the hearts of successive generations of supernovae. So, how does a civilization from a metal-poor region of the galaxy build an object that appears to be made of refined, exotic metals, including pure nickel without iron? How do they achieve a level of industrial chemistry that far exceeds our own, when the raw materials should not have been available to them in the first place? Right now, as this origin plot is confirmed and reconfirmed, the last vestiges of conventional explanation are evaporating. The object is not just an anomaly in its composition and behavior, it is an anomaly in its origin. It is an emissary from a place that shouldn't have the materials to build it, on a journey that shouldn't be possible, displaying a technology we do not understand. The final piece of the puzzle has not solved the mystery, it has made it infinitely larger. Chapter 16, Part 2, A Million Visitors in the Dark. The final analysis on your screen is not an observation, but a calculation. It's a statistical extrapolation, a piece of cosmic arithmetic that is perhaps the most unsettling discovery of all. You are looking at an estimate of the total population of interstellar objects passing through our solar system based on the 3 we have now detected. The calculation is simple. We have been actively searching for these objects for about a decade. In that time, we have found 3. 2 of them, Oumuamua and 3I Atlas, belong to a class of objects that display multiple independent signs of being artificial. Given the tiny sliver of the sky we are able to monitor, how many such objects must be passing through the solar system at any given time for us to have seen 2 of them in just 8 years? The number that the computer returns is 1 million. To account for our detection rate, there must be, on average, 1 million such objects passing within the orbit of Neptune at any given moment. The solar system is not being visited, it is being surveyed. This is the final crushing weight of the data from the Perihelion test. It is no longer possible to see Oumuamua and 3I Atlas as rare, one-off events. They are samples from a vast unseen population. They are the 2 we happen to see, the 2 whose trajectories happen to bring them close enough to our telescopes. The space between the planets, which we once thought to be empty, save for the occasional natural comet, must be teeming with these silent, dark, fast-moving visitors. Right now, as you stare at that number, the implications are overwhelming. We are not just confronting the existence of a single anomalous object, we are confronting the existence of a systematic, galaxy-spanning presence. The silence of 3I Atlas takes on a new, more chilling meaning. It is not silent because it is broken or dormant. It is silent because it is one of a million, a drone in a vast and silent fleet performing a task we do not understand, for a purpose we cannot conceive of. The Perihelion test of 3I Atlas began as an attempt to prove that an anomalous object was natural. It has ended with a statistical argument that our solar system is, and perhaps always has been, under quiet, continuous and pervasive surveillance. The darkness between the stars is not empty, it is full, and we are just now, for the first time, beginning to see what is moving in it. Chapter 17, Part 1, The Vera Rubin Observatory, A New Eye on the Sky. On a mountaintop in Chile, a new eye is opening to the cosmos. The Vera Rubin Observatory is not like other telescopes. It is a survey instrument, a sentinel. Its mission is not to stare at one object for a long time, but to scan the entire southern sky every 3 nights, creating the deepest, most comprehensive movie of the universe ever made. It has just achieved first light, and its first operational directive, issued with the highest priority, is to find more. The data from 3I Atlas has changed everything. The statistical calculation that suggests 1 million such objects may be in our solar system right now is no longer a fringe theory. It is the central driving question of planetary defense and astronomy. The search is now on in earnest. You are in the Vera Rubin control room as the first night's data is processed. The 8.4-meter mirror and its 3.2 gigapixel camera have just ingested petabytes of information. The powerful data pipeline is now sifting through it, looking for the telltale signature of an interstellar visitor, a point of light moving too fast. On a hyperbolic trajectory, the software is running a new algorithm, one designed specifically to look for the anomalous properties of Oumuamua and 3I Atlas. It is looking for objects that are dark, fast, and not outgassing. It is a search for needles in a cosmic haystack. Right now, as we speak, this is the new frontier. The perihelion test of 3I Atlas was a reactive event, a scramble to study an object that had already arrived. The era we are now entering is a proactive one. Vera Rubin will not wait for these objects to come to us. It will find them far out, as they are still approaching, giving us months or even years of warning. The discovery of 3I Atlas has triggered a paradigm shift. The search for extraterrestrial intelligence is no longer just about listening for radio signals from distant stars. It is now also about looking for visitors in our own backyard. As you watch the data scroll across the screen, you realize the story of 3I Atlas is no longer just about what it is. It is about what it has forced us to become, a civilization that is finally, actively looking for our neighbors. The perihelion test revealed a profound mystery. The Vera Rubin Observatory is humanity's answer to that mystery. The silent, systematic survey of our solar system is about to be met with a silent, systematic survey of our own. The watch has begun. Chapter 17, Part 2, The Galileo Project's Watch. The data from the global observation of 3I Atlas is not just being sent to NASA and ESA. A copy of every photon, every radio wave, every astrometric measurement is being mirrored to a small dedicated team at Harvard University, the Galileo Project, founded by Avi Loeb in the wake of the Oumuamua controversy. Its mission is simple and revolutionary: to search for extraterrestrial technological signatures using a rigorous, transparent, data-driven scientific approach free from the institutional inertia of mainstream astronomy. Right now, as we speak, their systems are analyzing the 3I Atlas data with a different set of assumptions. While mainstream astronomy has been trying and failing to fit the data to a natural model, the Galileo project has been doing the opposite. They are testing the hypothesis that the object is artificial. On your screen is their analysis of the object's light curve and albedo change. They have modeled the sudden drop in reflectivity not as a chemical change, but as a mechanical one. The model that provides a perfect fit to the data is that of a deployable structure, a vast reflective solar sail that was unfurled to maximize acceleration at perihelion, and then furled or reoriented once that maneuver was complete. The sudden darkening was not the object changing color, it was the object changing shape. Then you see their analysis of the water plume. They have modeled it not as outgassing, but as a small, precise course correction burn, or perhaps a heat dump, the venting of waste from an onboard power source. The isotopically pure nature of the water is, in this model, not a mystery but a feature. It is the signature of processed, manufactured fuel or coolant. The Galileo project is acting as a parallel scientific track, a control group for the consensus. They are taking the exact same data and asking a different question. Not, how can we explain this as a natural object, But is this data consistent with a technological object? And the answer from every single dataset is yes. This is the new reality in the wake of 3I Atlas. The scientific debate is no longer between a comfortable consensus and a fringe theory. It is now a legitimate, data-driven schism between two competing paradigms. On one side, a desperate attempt to invent new forms of natural comets to fit the observations. On the other, the simple, terrifying conclusion that the object is exactly what it appears to be. The Perihelion test has ended, the data has been collected, and now the true test begins, the test of whether the scientific establishment can follow the evidence, no matter how extraordinary the destination. Terptimtorm, Chapter 18, Part 1, The Case for a Natural Origin. In a lecture hall at the University of Arizona, a planetary scientist stands before a room of her peers, making the case for the opposition. The data from 3I Atlas may be strange, she argues, but strange does not mean artificial. The universe is a far more bizarre and varied place than our limited experience has led us to believe. We have studied, in detail, less than 0.1% of the comets in our own solar system. To assume we understand the full range of possibilities for comets formed in entirely different star systems is an act of profound arrogance. On the screen behind her, she presents a model. It is a composite, a Frankenstein's monster of a theory, but it is a natural one. She proposes that 3I Atlas is a fragment from the iron-nickel core of a shattered planetesimal, giving it the structural integrity to survive perihelion. This core fragment, she argues, was then coated in a thin, meters-thick veneer of exotic ices, perhaps nitrogen or solid hydrogen, during its long journey through an interstellar molecular cloud. This thin veneer of ice, she explains, would sublimate invisibly under solar heating, providing the gentle, continuous thrust that explains the acceleration. The underlying metallic body would explain the high albedo and the strange nickel without iron signature. If one assumes a highly unusual and specific formation chemistry, the sudden darkening event, a complete and rapid sublimation of this thin reflective ice layer, exposing the dark metallic core underneath. Each piece of the explanation is, on its own, highly improbable. But improbable is not the same as impossible. Right now, as we speak, this is the argument that is holding the line for the natural origins camp. It requires us to believe in a series of extraordinary coincidences and new types of cosmic objects for which we have no other evidence. But it does not require us to believe in aliens. And for many scientists, that is a far more comfortable position. The principle of extraordinary claims requiring extraordinary evidence is the bedrock of scientific skepticism. The data from 3I Atlas is extraordinary. But is it extraordinary enough to overturn our understanding of our place in the universe? The case for a natural origin now rests on this delicate chain of improbabilities. It is a theory born of necessity, an attempt to find a place for 3I Atlas within the known laws of nature, however strained. But with each new piece of data, that chain is stretched thinner and thinner. The final definitive test is now just hours away, as the Europa Clipper prepares to fly through the object's wake. If it finds even a trace of this exotic, invisible propellant, the natural explanation will be saved. If not, the chain will break. Chapter 18, Part 2, The Trail of Unexplained Anomalies. The argument for a natural origin is compelling in its conservatism. It does not require a leap of faith, but it has a fatal flaw. To accept it, you must accept that a single natural object can simultaneously possess a whole suite of impossibly rare and often contradictory properties. You're back at the whiteboard, staring at the list of anomalies from 3I Atlas. It is not one mystery. It is a cascade of them. Consider the composition. To be strong enough to survive perihelion, it must be a solid metallic body, but to accelerate it must be outgassing like an icy one. It cannot be both. Consider the albedo. To be so reflective, it must have a surface of pristine, clean ice. But to show no signs of sublimation at perihelion, that ice must be covered in a thick, insulating crust. It cannot be both. Consider the trajectory. To arrive on such a statistically improbable low-inclination path is a profound coincidence. For that to happen twice in a row, with Oumuamua and now Atlas, stretches the definition of coincidence to its breaking point. Consider the activity. The object is inert and passive when it should be active, then suddenly active when it should be passive, venting a plume of isotopically pure water that has no business being there in the first place. Right now, as you look at this list, the true weakness of the natural explanation becomes clear. It is not that any single anomaly is impossible to explain. It is that explaining all of them at the same time requires a natural object so contrived, so perfectly designed to fool us, that it ceases to be a plausible natural object at all. This is the core of the anomaly argument. The artificial hypothesis does not require a long chain of independent, low-probability events. It requires only one. From that single assumption, all the observed data flows logically. A technological probe would be designed to be strong, it would be designed to be maneuverable, it would have a hull made of refined materials, it could be designed to use the sun for a gravitational assist, and its own systems for propulsion. The Perihelion test was supposed to force 3I Atlas to choose a side, to declare itself as either a natural comet or something else. It has made its choice, and now the scientific community must make its own. It can continue to construct ever more elaborate, improbable natural explanations, or it can face the data and the profound, transformative, and terrifying possibility that we are not alone. Chapter 19, Part 1, Behind the Sun, Waiting for an Answer. In the Europa Clipper mission control room at JPL, the mood is one of profound, suspended animation. It is 16 SOTA UTC, November 6th. For the last 2 hours, the spacecraft has been out of contact, its trajectory taking it behind the sun from Earth's point of view. This solar conjunction was unavoidable, a predictable quirk of orbital mechanics. But its timing could not have been more dramatic. Just before the blackout, Europa Clipper entered the predicted wake of 3I Atlas. Its particle detectors and magnetometers were active, its high-gain antenna pointed toward Earth, streaming its final bits of telemetry before the sun's overwhelming radio noise drowned it out. For the next 8 hours, the spacecraft will be on its own, flying through the very region of space that holds the final definitive answer to the mystery of 3I Atlas. On the main screen, the last data packet received before the blackout is frozen. It shows the background radiation of normal interplanetary space. The particle count is nominal. The magnetic field is quiescent. This is the baseline, the control measurement taken just before the fly-through. The next data packet, the one that will contain the measurements from inside the wake, is already stored in the spacecraft's onboard memory. It is sitting there, 200 million kilometers away, waiting. Right now, as we speak, the entire scientific world is waiting with it. This is the final act of the Perihelion test, the one direct measurement that can confirm or deny everything that has been inferred from a distance. If that next data packet shows a spike in exotic particles, in strange magnetic fields, in any kind of invisible propellant, then the natural origins camp will have its saving grace. The acceleration will have a cause, however strange. But if that data shows nothing, if the particle count remains at background levels, if the magnetic field is undisturbed, if the space behind this accelerating object is as empty as the space in front of it, that silence will be the loudest signal of all. It will be the final irrefutable piece of evidence that the force-pushing 3I Atlas is not outgassing. It will be the data point that breaks the stalemate and forces a paradigm shift. You watch the countdown clock on the screen, ticking down the hours, minutes, and seconds until the spacecraft emerges from behind the sun. 8 hours of silence, 8 hours to contemplate the two possibilities. Either we are about to discover a new law of physics, or we are about to receive confirmation that humanity is no longer the only builder in the cosmos. Chapter 19, Part 2, An Invitation from the Universe. The signal acquisition tone chirps through the speakers at the Europa Clipper mission control. It is 0001 UTC, November 7th. The 8 hours of waiting are over. The spacecraft has emerged from behind the sun. Its antenna is locked onto the deep space network, and the data from its fly-through of 3I Atlas's wake is pouring in. You watch the screen, your heart pounding. The data appears as a series of graphs: particle density, magnetic field strength, plasma composition. This is it, the ground truth, the moment of direct contact. The graphs resolve, and they are perfectly, beautifully, terrifyingly flat. The particle counter shows no increase above the background solar wind. The magnetometer shows no disturbance. The plasma wave instrument detected no turbulence. The space behind 3I Atlas is empty. There is no invisible propellant. There is no cloud of exotic particles. There is nothing. The acceleration of this interstellar visitor is not caused by outgassing. It is not caused by any form of propulsion that ejects mass. The last, desperate hope for a natural explanation has just been extinguished by a stream of radio waves from 200 million kilometers away. A single, undeniable fact now stands before the scientific community, stripped bare of all conjecture and debate. An object the size of a small mountain is being pushed through our solar system by a force that has no physical cause. Right now, as this data is being shared, the world has changed. The institutional panic that has been simmering for a week has just been validated. The career-defining risk of accepting an extraordinary conclusion has just become less risky than the career-ending act of denying the undeniable evidence. The Perihelion test is over. The sun did its work, and the verdict is in. 3I Atlas is not a comet. It is not a nitrogen iceberg. It is not any natural object that we can conceive of. Its behavior is consistent with only one explanation: a solar sail, a piece of advanced technology, a probe from another civilization. What began in 2017 with the fleeting, ghostly passage of Oumuamua has reached its stunning conclusion. We are not alone. This is no longer a matter of belief or philosophy or statistical probability. It is now a matter of direct observation. The universe has sent us not one, but two messages. We have spent decades broadcasting our own signals into the silent dark, hoping for a reply. It seems the reply has come, not as a radio wave, but as a visit. The data doesn't lie. It is an invitation to a much larger cosmos than we had ever dared to imagine. Chapter 20, Part 1, The Silence Between the Stars. The observation window has closed. The last of the data from the Europa Clipper fly-through has been analyzed and confirmed. 3I Atlas is now receding from us at over 40 kilometers per second, growing fainter with each passing hour on its way back to the interstellar dark. It has left behind a trail of broken theories and a single, profound, and now unavoidable truth. You are sitting in a darkened auditorium, listening to the final summary of the findings. The screen is filled with the cold, hard facts that have accumulated over the past 10 days, the acceleration that cannot be explained, the composition that should not exist, the trajectory that should not be possible, the behavior that cannot be reconciled with nature. The Perihelion test of 3I Atlas was designed to be the definitive answer, the moment when the sun's crucible would force this strange visitor to reveal itself as just another exotic comet. Instead, it has become a final examination for humanity, a test of our ability to accept evidence that contradicts our most deeply held assumptions. We have now seen 3 visitors from the stars. 2I Borisov was exactly what we expected: a primitive, icy remnant of planet formation from another solar system. But the other 2, Oumuamua and 3I Atlas, were something else entirely. They are a new class of object, defined not by what they are, but by what they are not. They are not comets. They are not asteroids. They are not any natural phenomenon for which we have a theory. Their properties are, however, entirely consistent with the properties of a technological artifact: a probe, a solar sail, a piece of interstellar derelict. This is no longer a fringe hypothesis. After the Perihelion test of 3I Atlas, it is now the simplest explanation, the one that fits all the facts. The silence from these objects is perhaps the most profound message of all. They do not announce themselves. They do not communicate. They simply pass through, using our star for a gravitational slingshot, their presence betrayed only by the subtle, precise way they defy the laws of nature. The story of 3I Atlas is not an ending. It is a beginning. It is the moment when the search for extraterrestrial intelligence moved from the realm of radio astronomy to the realm of direct physical observation in our own solar system. We have been looking for a message from the stars. The Perihelion test of 3I Atlas has delivered it. The message is that the stars have already been here, and they will be back. The only question now is, what do we do next? Chapter 20, Part 2, Looking Up Again. You step outside into the cool night air, away from the screens and the endless streams of data. You look up. The tapestry of stars is the same one humanity has looked upon for 100,000 years. The planets are the same familiar wanderers. The sky looks the same, but it is not. A single 10-day passage of a silent visitor has changed it forever. The void between the stars is no longer a void. It is a space that is traveled. The darkness is not empty. It is a road. The Perihelion test of 3I Atlas is complete. The sun, our sun, performed its relentless experiment. It asked a simple question: are you a comet? Are you a piece of nature, born of ice and dust and time? And the answer, written in a language of physics so clear it cannot be misunderstood, was a resounding, definitive no. In the end, it was not one thing. It was everything. A trail of evidence so long, so consistent, and so strange that it overwhelmed every alternative. An object with the strength of metal, the acceleration of a rocket, the chemistry of a refinery, the trajectory of a chosen path, and the silence of the void. An object that is, by every available metric, technological. The panic in the halls of science is not one of fear. It is the panic of a paradigm collapsing. It is the vertigo of standing at the edge of a discovery so profound it will redefine our species. The implications are not yet understood, but they are felt. A deep, seismic shift in the foundation of everything we thought we knew about our place in the cosmos. What began with a faint smudge of light in a telescope has ended in the greatest discovery in human history. We looked for a message from the stars, and we found a messenger. We are a part of a conversation that has been happening, silently, all around us for eons. Our quiet, lonely corner of the galaxy is and has been a place of passage. The story is no longer about 3I Atlas. It is about us, about what we do the morning after, about how we live in a universe that we now know for a fact we do not inhabit alone. The silence between the stars is not the silence of emptiness, it is the silence of a vast and patient cosmic neighborhood. And for the first time, we are truly beginning to listen.